All right, so this is the memo for core test 2. The first question was asking you to identify the various compounds and identifying whether they're Lewis acids or Lewis bases. This is a really important thing in chemistry, is recognizing this concept. The question was only 2 marks, but you had to get everything right to get the 2 marks. There weren't partial marks because, of course, looking at a particular compound and saying whether it's an acid or base is a 50-50 chance. So it had to either be all right or all wrong. There's a metal over there, no lone pairs of electrons on typically Lewis basic atoms. So whenever you see metals like this, Lewis acid is to be thought of. Nitrogen, lone pair of electrons, definitely a Lewis base. Phosphorus, below nitrogen, always a lone pair of electrons, definitely a Lewis base. Nitrogen, lone pair of electrons, definitely a Lewis base. Aluminium metal, definitely going to be a Lewis acid. This one looks a bit different, but actually remember boron is the same as aluminium. It's just above it. So actually conceptually both of those are identical to each other. This is a Lewis acid. Boron has this empty p orbital that can accept electrons. It is Lewis acidic. Okay, so this is fundamental work. The next question here has to do about ranking bases, and this sort of question comes up in almost every single test and assessment once we've covered this work, which we've done now. And it's always very, very easy. There's normally about 4 different things that you need to rank. And we go from strongest to weakest, and always the carbon is the most strongest because the pKa of a CH is about 40 to 50. So the base is very, very, very strong. The next strongest is always an N minus because an NH, the pKa of that is about 35. So that'll always be the next strongest. And then the oxygen, plain oxygen, all of these are plain. So carbon, oxygen, nitrogen, no resonance stabilization, so that oxygen over there will be the next one. pKa of alcohol is about 16, so 1, 2, and 3. This one over here is not negative, it's going to be a lot weaker than the rest of these over here, and so it by default must be the lowest one. Normally there's one other question or one other compound in this series, these types of questions. And you just have to compare it. Sometimes it might just be also an oxygen, but it can undergo resonance, and then that would be weaker than this oxygen. So just look at it from that perspective. This mechanism type question is really, really important to be able to master something like this. I gave all the information that you needed here. I've given charges on atoms, which you should have actually been able to work out yourself, but that is which is also a core principle, but I've given that here to you. Each step is just an individual thing. You don't have to see all of this and think, oh, there's like lots of information here and it's too much for me to take in. Actually, this is just one question here, one question here, one question here, one there, and there's nothing in the answer. It's 5 marks. So we saw that here you can look from going from starting material to product. The bromine has left, and there's a new bond between phosphorus and this carbon. There's the carbon over there, so the lone pair of electrons must have added to that carbon over there, and then that bond broke. Notice it's very important. This is where the electrons start. They're going to that carbon. The electrons are in the sigma bond of the other. So they start and they end up on the bromine, and so we get that product over there. The next thing is going from here to here. We look at it very carefully, and we notice that there is one less hydrogen. So the hydrogen has been picked up, and it must have been picked up by a base. And butyl lithium, what you should know from your bases, is a very, very strong base. And so the alkyl lithiums, or this carbon lithium bond, or if it's carbon magnesium, it's the sigma bond that is what's going to react, and it's going to act as a base and pick up that proton over there. Notice the sigma bond is going to the proton, and then this bond has to break to leave a minus on the carbon. So the arrow is very small and looks like that, going onto the carbon over there. All right, so that gives this one over here. This one might have been a little bit more difficult. This one should have been very easy because there's a negative. Okay, it's that carbon, and then this carbon over here is this one, so the bond is forming between those two. This makes sense. We've got a minus, which is a nucleophile, lone pair of electrons, attacking a carbon, which is electrophilic, and we can break that pi bond. So the curly arrow can add to this carbon and break the pi bond like that, and we would end up with this. Going from there to there is also incredibly simple. All we're doing is we're taking the negative charge, which is a lone pair of electrons, and going to the phosphorus. So that's happening like that. That's a very simple arrow to draw. Going from here to here is actually perhaps one of the more difficult questions, what we gave. But actually, you need to recognize that the oxygen is now double bonded to phosphorus, and there's a double bond to the carbon. So there's actually, it doesn't matter which direction you actually push these arrows. It's fine, but we can take this set of electrons over there and push them in to form a double bond. And of course, this has to break, and I can push in this way and form a double bond to the phosphorus over there. So, and you could have maybe done the arrows the other way, from there to there, and then coming down that way. So they're moving in the opposite direction. All right, so that's just the mechanism, and this type of thing is really important. I'm going to put a question like this in your class test. This, technically speaking, is the Wittig reaction. You may have done it by now, but you should be able to answer any question of a mechanism that you have not seen before, just by following the rules of mechanisms and being able to show the movement of arrows. The last two questions here were actually rather, certainly this was very trivial. DMF, you should be able to just draw out. That's dimethyl formamide. Okay, that's just a standard solvent. And dichloromethane is two chlorines on a carbon with two hydrogens on it. Dichloromethane. Okay, sorry, my writing is a bit messy there. This one over here, I give a definition of a nucleophile. There's actually a whole lot of different things, and this question should have been marked fairly leniently. Essentially what we're looking for here is a nucleophile has something that has lone pair electrons to donate to an electrophile. Okay, that would have been fine. However, there are many other options over here. You might have spoken about a nucleophile being a Lewis base. You might have spoken about it being related to being a base. You might have spoken about a nucleophile being a molecule that uses its HOMO to donate its electrons to the LUMO of another molecule. That's correct as well. So there's a number of different things that would have been acceptable over here. It's a little bit more open-ended, but what I was looking for here is, can you just give a fundamental definition of a nucleophile that makes sense? Obviously, if you said something completely incorrect, then that wouldn't have given you any marks. All right.